welcome to Physics 536, Computational Physics for Educators. I want to welcome you to the class. I am Matt Wood. I have been doing scientific computation for over 30 years, including my PhD thesis on white dwarf evolution. I've been doing Python for over 10 years. This is my first time teaching this specific course on computational physics, but I have taught computational physics at the undergraduate level and the graduate level, and using Mark Newman's very nice book for that. So you're in good hands. A little bit about me. I am originally from Iowa, grew up in the Des Moines area, West Des Moines area. I got my bachelor's in physics from Iowa State University. I got my MS and PhD degrees from the University of Texas at Austin in astronomy. I spent 1 year in Montreal as a NSF NATO postdoctoral fellow, and then I was hired on to the Florida Institute of Technology back in 1991. And I spent 20 years there working my way up through the ranks. In 2011, Dr. Curtis Williams here emailed me and said they were looking for a new department head. I applied. It was a good time for me, and I got hired. So I started in 2012 as department head, served as department head for 5 years, was asked to serve in the upper administration as the dean of the graduate school and vice provost for research. It was interesting, but I really missed being with the students, and I missed what I love, which is being in the classroom. So after about 1.5 years of that, first job I had since selling shoes in high school that I wasn't having fun, decided I'm going to go back to faculty. So absolutely worth the pay cut to do that. My research is in astronomy. I do cataclysmic variable stars, which are close binary systems with mass transfer between, so there's some computational hydrodynamics involved with that, and then also white dwarf stars and using those as cosmochronometers to help understand the age and star formation history of the galaxy. On a personal side, I love to travel with my partner, my wife, who is an econ professor here. Got my pilot's license about 5 years ago, and so we sometimes on the weekends will fly off for what they call $100 barbecue. I also play some music. I play bass guitar and guitar. Not good, but have fun at it. Like to bicycle, and lately I've been playing a little bit of pickleball, right? So life was a little bit too cozy for us, and so we recently got a puppy, golden retriever. Her name is Poppy, the flower, and so that's fun, and yeah, you know, if you've had puppies. Please do post about yourself in the forum on the Discuss Yourself forum. Share as much as you want or as little, and I do look forward to getting to know you. All right, so let's move on and talk about the syllabus. So my physical office is in 343 of the Science Building, and if you live close enough and you'd like to meet face-to-face, love to meet you face-to-face, so just let me know. We will set something up. Office hours will be virtual. They will be Tuesdays at noon on Zoom. And the reason I picked noon is I figure everybody can take a break at lunch. These are optional, I should say. For the second half of our course, so July, I'm going to actually be in Istanbul, Turkey, which is where my partner is from. And so we go there every year. And so that will be 8 o'clock in the evening for me. If we did something like 6 o'clock at night, that would be 2 in the morning for me. And I love you, but not that much. All right. So if that doesn't work for you, let me know. We can work something out and have just a one-on-one Zoom or something. We will have our first office hours the very first week of class. That might be a good time if you're having any installations or anything that you want to talk about. Again, they are optional. Let's see. I'm going to try something new, a Slack workspace, and I will send out the invites for that. And you should even be able to just get in there based on the information that's posted in D2L. I think that will be a faster way for us to communicate. It's a messaging service, and so we can give that a try. So there's desktop applications, there's phone applications, and you can set up notifications and things like that. So we'll give that a try. If it doesn't work, we can go back to just, discussion forums and emails and things like that. But let's give it a try. Let's see. Textbook. coming down to the textbook here. So Newman is the required textbook. It's a very nice textbook. And then I have a recommended textbook here, which is Garcia's Numerical Methods in Physics. And that is completely optional. We're not really going to use it at all. I just put it up there because I think it's $15 on Amazon. So if you want to have a second reference for computational physics with Python, that's a nice one to have in your personal library, but again, not required. We will have some readings during the semester on computational physics, physics education research, and so those are kind of listed there in the syllabus, and we'll talk more about that later. But basically, you will be doing a reading reflection on a paper, and you will kind of write that up, and there is a rubric for how it's going to be graded, and so you'll post that, and then you will do 2 reply posts to other students, and if you've had any of our PER courses already, then you kind of know the drill. All right, and let's see. We'll also have discussion posts on the homework topics, and so there you will have 1 thread starting post and at least 1 reply post, and of course, so that adds up to potentially up to 5 posts per week. And of course, you are welcome and encouraged to do more than the minimum. So the more that we can all engage with each other, I think the more we will all get out of it. All right, so the course grades, let me skip down to that, are sort of the standard 90, 80, 70, 60. In these courses, usually students do very, very well. I love teaching these courses for our online Masters in Physics for educators because you all are just great. Absolutely wonderful classes all the time. So grade's going to be based on 5 components. So we've got 45% for a midterm exam and a final project, split equally between those two, 20% for the problem set homeworks, 15% for the reading reflection homeworks, 10% each for the problem discussion and the reading discussion. And so we'll talk a little bit more about that as time goes on. I will notice here that the assignments for the homework will be graded about 70% just for effort and 30% for correctness. So if you don't, get it all the way, that's going to be okay. Engaging with the material in a meaningful way is the most important thing. All right, so a little bit more on the reading reflection, so I'll let you do that on your own time, and all the boilerplate stuff that we have to include. And so finally down here, course outline and calendar. So some of you may have no prior experience with Python or even programming at all. So I understand that can be a little bit daunting. So week 1, we're just going to have the basics, introduction to Python, how to work with a Jupyter notebook, how to do arrays, how to work with built-in functions and things like that. Week 2, more introduction to Python and how specifically we would introduce traveling waves, how we would make some plots of things, how we might do some simple animations in our Jupyter notebooks. Week 3, we're going to go into functions, libraries, and here we've got the traveling wave, so that's actually where the animations will go. So week 4, plotting, superposition, 5, integrals and derivatives, and then plotting and diffraction patterns. Week 7 will be introduction to spreadsheets and how we might do some simple numerical methods in spreadsheets. And let me know. So this is something that the previous instructor of this course included, was using spreadsheets. And I'm happy to do that. It's not something I've done before. If instead you would like to have a deeper treatment of Python, then let me know. And if it's a consensus that we do that, then we'll do that. And we can talk about that over Slack or in the discussion forums. And then differential equations and oscillations, and then a little bit on chaos. So double pendulum, Feigenbaum plots, things like that. Mandelbrot sets, all that good stuff. And so here are the homework set deadlines and the reflection homework deadlines. And there's the due dates for the exams. And so I think we're all set. And again, I really look forward to getting to know you. I'm looking forward to working with you in this course. Please do let me know via email, discussion forum, Slack, what you hope to get out of this course. I'll see you next time.